Our next speaker is Professor Dan Keefe from University of Minnesota, and he'll tell us when to walk into your data.
Very good. Thank you, George. Thank you for the invitation. And my name is Dan Keefe. I'm from the University of Minnesota. If you see me with a perpetual smile on my face, it's because it was 14 degrees when I got on the plane yesterday. So I'm very happy to be here for many reasons. And let's see now. In our lab, I direct a lab we call the Interactive Visualization Lab, and we work on many problems that involve data. Our solution to helping people analyze that data is through taking advantage of the visual system. So everything's visual, but it's also highly interactive, and that's really where I want to focus on most today. So we've looked at brain data and fluid flows, climate data, as well as in biology, other data sets, biomechanics. Many of these things have that complex spatial relationship that we were talking about earlier. Okay, but the more we've been working with this and the more we've been thinking about employing these virtual reality techniques, the question comes up, like, when do you really want to do this? Okay, when is it a win? And so I sort of posed that as, I mean, it's kind of crazy. Like, does it ever actually make sense to walk through your data? When does that make sense? And I want to share with you a couple of things that are a little different. This comes from some public art, okay? But this has actually shaped my perception of the answer to this question. When does it make sense to walk within your data? And as someone working on visualization, I actually have an art background myself, but the projects I'll show you here are the first times that I've worked with an interdisciplinary group, including architects, to bring art to sort of public spaces. So let me show you just a quick sense of this. For this Northern Spark Art Festival, our group got together and we were supposed to create a piece inspired by climate chaos. That was the theme. And our thinking, of course, this is for consumption by the public, so our thinking was in large part around this idea of how do regular people, non-scientists, think about climate? And what discussions do they have? And these are some of the things that came up. When I was a boy, it wasn't like today. We always had enough snow to ski. Of course, you can see where I'm coming from with a statement like that. Okay, but this is how people relate to it, okay? And so, but there's sort of this disconnect, the way we talk about climate and in this objective, data-driven world. So this inspired a concept that I'll just show you briefly. I'm going to breeze over this. But basically, the idea was to juxtapose an objective data set with a subjective data set, where the subjective was actually created by visitors to the piece based on their memories of weather. The details of the data, in some sense, don't matter here. What matters is the setting and the experience it created. So this is right along the Mississippi River in Minneapolis, and here you see this tunnel that we're going to light up with data. And it turns out there is actually a pretty sophisticated, maybe a little too sophisticated, mapping of data to this display, but this wasn't intended really to do analysis, again, for the experience. So let me show you that. you'll see in a moment, the way people entered data, there was a kiosk with a touch screen. And So they were asked to select a date when they had a strong memory of the weather. A lot of people picked the Halloween blizzard of 1991, or the day their daughter was born, or something like this. And after making the selection, they were then asked, well, what was the weather like on this day? And this is their manual entry of data. So you've heard of big data, this is kind of like small data. And then they were asked to act out their memory of the weather. And this is a multi-touch screen, so you could actually use all your fingers. I think this person's drawing a car with some rain. And then that animation, they have 10 seconds to make an animation, gets played back on the screen. So it's almost like playing a giant instrument. So this was a really playful experience, an engaging experience, and it had its own sense of immersion. And I think it was particularly powerful because of the physical space of it. This year, the same group worked on another project, which involved data-driven sculptures. Each module of these tripod-like things represents one bird species, and so they're tied to data, and these were actually built. Next Sunday, you may see this view, because the Super Bowl will be held here. So these were installed right in front of the US Bank Stadium. People were walking through them. Okay. So the key for me, again, these are a little outside the norm for me, but I wanted to share with you because the key is experience. What is the experience you have relative to your data? And even these physical styles of immersion produce an experience. Okay, so that's the first kind of mini answer to this question. What I'd like to do now is talk more about some technical details and some examples from our virtual reality work. Okay, so how do we do this kind of experiential analysis in virtual reality with the kind of data sets that we really care about? And I want to show you 3 examples here. Okay, so the first is oriented towards design. How do we do design in virtual reality? Okay, it could be design of scientific visualizations, could be design of mechanical structures, could be almost anything. But what does that process of creative design work look like when you move it into a virtual realm? And I would say that one of the things that really makes that possible is a fluid interface. So this is some really early work that I did as part of my dissertation. I hope you can make it out. These are dark old videos. But the point is that we're working in space. Okay, and we're doing things here with a 3D tracked brush that you can't do with a mouse. Okay, there's a level of gesture and control of the hand where form reflects the artist's movements in a way that you just can't do without this kind of input. Okay, and then you can be fun and pretend you're pouring paint out of a bucket and have no cleanup. Okay, so with this, I mean, it takes some getting used to. You have to learn to think in 3D, and you're no longer painting on a page, you're painting in space. Okay, but you can create some pretty amazing work. And one of the things that's quite interesting about this, even artistically, is there's evidence of the human hand in this. It doesn't look like a computer-generated, watertight mesh. We can see that somebody made this. Okay, so it's human design work in a virtual reality space. Now, one of the challenges we had with this is that it does have that gestural quality, but sometimes that's not what you want. What if you want to apply this to something that's more exact? The other problem we had is sort of a general problem of working in virtual reality. You go into these spaces and you leave the rest of the world behind. So what happens if you made some sketches that are part of your inspiration, or you have a lab notebook? All of a sudden we say, here, come into a blank space and be creative. Okay, it doesn't work so well. So this is one example, really the first example for us of what's now becoming a theme of trying to bring information from outside of virtual reality into immersive spaces. So this is also a 3D modeling system, but the great thing is we can import hand-drawn sketches. And then we place these in space. You can hang them in space, put them wherever you want. And then these serve as context, so then you can work off of those. And so now we're pulling lines from those sketches out into a 3D space. And you can create some pretty incredible things that actually would be very difficult to do in a completely freehand way, but with the benefits of that ability to work in space. And so again, we've used this in my lab because we're interested in art and architecture. We've done things like that. But we've also expanded this into mechanical design. So here's an example of designing a surgical table. And the engineers who were working with this wanted to look at alternative designs. So the same way you'd sketch on the back of a napkin, you sketch in VR. Or you sketch on your napkin and bring it into VR. Okay, so it gives you quick prototyping ability in 3D. Actually, let me pause for a second. The next extension of this, which I'll show you now, is the idea of sketching on top of more sophisticated data. Instead of just bringing a sketch in, how do we design data visualizations in the target medium? So in many ways, this is similar to what Alex discussed earlier. Rather than having all these knobs where you control a color mapping, for example, how do you just indicate to the computer what color mapping you want and have it figure out the details? So this is an example in 2D, but we're now working to extend this into 3D. And here we're looking at climate data. This is actually a terabyte of climate data. And interactively, what we can do is paint. We can say, gee, this area of temperature should be orange. And we can indicate that simply by drawing on the data visualization. There's no mapping with off-screen panels and so forth. We just say, you know what? I want this to be white. And the computer figures out, okay, well, if you want that to be white, I need to make it an accurate visualization. So I'm going to have to infer the data to color mapping that you're indicating, and then apply that to the rest of the data set. The implication, though, is you can design data visualizations the way you would as an artist. It's like using Photoshop, but for data visualization. Okay? And we can extend the same idea to sketching the shape of glyphs. We then give a panel of exemplars of different density mappings for the glyphs that you design. So you just click on those. Rather than using a slider, even we give you a preview. And the results, what's really special about them is that, again, this is accessible to artists. So we can take someone who's a trained artist, like my collaborator, Francesca Samsel, and she can create these multivariate data visualizations, all built up in layers, which look fantastic. I mean, doesn't this look more like an oil painting than your typical visualization? It's because we've given the tools that are accessible to people through the interface. Okay, so that's on its way to VR. Let me show you now another project. This is a little different for us. Rather than a scientific data set, we're working with a scholar of ancient rhetoric. He's in the classics department at the University of Minnesota. And our collaborator, Richard Graff, is interested in the hillside of the Pnyx. So in ancient Athens, this was the birthplace of democracy, the official meeting place of the assembly. And so this is where speeches would be given, and the citizens would vote, do we go to war, do we not, this sort of thing. Okay? So it's of enormous significance culturally. And the thing that's so fascinating is that it underwent these amazing changes over 3 historical phases. So in phase 1, the speaker stood here and spoke to an audience that occupied the hillside. Okay. In phase 2, for some reason, they reversed this, and the speaker stood up high, facing down the mountain. This meant, no machinery. They had to haul in enough earth fill to reverse the slope of the mountainside. So why did they do that? So this is one of the questions. And what would it have felt like to give this? Was the sun in their eyes? I mean, there's all these interesting questions. This is the first time they voted, so why did they switch from 2 staircases to 1? Did it have to do with like handing in a token when you vote? There's all these interesting questions. And it's the kind of thing that's very difficult to understand without being there. Okay. So again, experiential analysis. What we have done here is made a virtual reconstruction of this, and there's a couple of interesting details that will be fun to notice. I'll play a short video of this, and you'll see some navigation by using a touch screen. So this approach integrates a 2D visualization, which basically is giving you a map, but it also serves as a touch control. So you have some pretty accurate touch input to the environment, and that allows you to move around through the visualization. There's a crowd simulation that we use to populate this to get sort of appropriate placement of the people. But then, you know, there's subtle things here. Okay, here's some rotation and navigation around. There were things that our collaborator noticed, you know, when he's standing here and he's saying, aha, people would have had to stand up on the hillside. You know, because there's a question, how many people would be in this? What was it, 6,000, which there's evidence in the text that was needed for a quorum, but what if it were 7,000? Did they need to actually spill up into this hillside or not? And of course, everybody's done these like geometric packings of people to try to answer this question, but you don't really get a good sense of it until you're there. This is another situation where we have one of these aha moments, where seeing something in virtual reality is just different. So this collaborator had been working with the 3D models you see here for months. He's working on his desktop computer with a 3D modeling program. Within 5 minutes of going into virtual reality, he notices a mistake. Oh, this is off by a factor of 3. How does he notice that? Well, because he's been to the site himself. And he said, I remember standing there, you know, and this rock over there is actually a lot farther away. So there's a sense of presence and judgment of scale that shows up immediately. Once you've noticed that, yeah, you can probably go back and find it on your desktop too. It's there in the model, okay? But seeing it happens sort of intuitively when you're in these environments. There's some other detail here that's quite interesting. I mean, here's a situation where because of that earth fill, the sites actually change in height. And so how do you facilitate that kind of analysis? And of course, in VR, we can fly wherever we want. We can fly underground and so forth. But how do you sort of give some context for what's happening when the world is changing in ways that we don't usually see? So we actually put a lot of thought into how to transition from one environment to the other. And you can see there's even like a meter stick that shows up when you do this transition to know, okay, you're rising up now to the ground level in this new phase. Okay, now the coolest thing here is that there's sort of this underlying research question, which of course you have no way to like really test until now, but you know, what would it feel like to give a speech to this many people? You have no microphone. You know, where was the sun? What did it look like? And so we developed a user interface that allows you to give this speech, and we measure how loud you're speaking, and then you see the results. So let me play this fun video for you.
Reform
Turn it up.
In ancient Athens gave authority to the people, giving rise to the earliest and what would be the most successful democracy in ancient Greece.
All right. We have an extreme case of experiential analysis here. Okay. All right, let me show you one more example here. Okay, now, here's a new problem. We're working with medical device engineers who are looking at cardiac leads in the heart. And they run finite element simulations. So they get fluid flow data and they get pressure data. But they run 10 of those because they're comparing different lead lengths and different lead stiffnesses. And so the question becomes, how do we not just see one of these? How do we facilitate comparative analysis? How does number 2 differ from number 6? And so on, okay? So this really ups the ante in terms of what we can do with visualization, because honestly, it's hard enough often to just show a single 3D graphical representation of 4 or 5 variables that works visually together. How do you do that when you know that the underlying scientific question revolves around comparison? Okay. Back up for a minute. Why are we doing this in VR in the first place? Because these are super complex 3D, actually 4D structures. Right? To understand this flow from looking at it on your screen in your near space is really hard. Okay. When you see it in VR, things start to fall into place spatially. Okay, so here is one approach that we created to solve this problem. And you can see that basically what we're after here is to spatially align these hearts. Okay. But we do that in a way that is designed to facilitate comparison. So in each column of this grid, we have one simulation. We'll call that one data instance. So a simulation where the lead length is fixed at 110 millimeters and it's got a certain elastic modulus. To the left or the right might be a different lead length. Okay, and we can rearrange the columns however we want. And then what we do is give the same view of each data set across the rows. So at the top you see sort of a default kind of zoomed out view of the entire data set. But then what's really powerful is we can create additional rows that zoom in on the areas we want to compare. Okay. Now, how do you do all that? It's with a 3D user interface. So we use 2 hands, and following best practices in the literature, we've figured out what the non-dominant hand should be used for and what the dominant hand should be used for. And then we allow you to interact with the data. So if I say, gee, I'm interested in this area called the appendage of the right atrium, where the lead attaches, what I want to do is select a subvolume of interest and then create a new row to sort of zoom in on that. Okay, and then I can see that across all the various instances of data. And there's some interesting math to make that happen. Okay, and then while you've got this up, of course, you can still interact with it. All this stuff is interactive, so you can reach your hand in and reorient even that little subvolume. And of course, the context is maintained with where that came from in the top row. We can create as many of these as we want. And you can adjust the whole grid. So we can click on, we can point to a little box and say, hey, zoom me in so I get a good view of that one. We can sweep out a selection of several and say, fit the view so it highlights these few. Or we can just grab onto the whole thing and sort of reorient it. So this is about navigating around your data set and doing that in a really fluid way. The other thing we can do here is start to adapt the visualization. So there's certain color maps when applied to the flow that really make the differences in the flow pop, differences in velocity, for example. And that works even better if we hide the stress information on the heart walls. But then on the other hand, we're also interested in stress. So we might want to create a row where the stress is highlighted. Okay, so we're sort of building up this custom visualization as we go. The magic behind this, I'm not going to explain this, but the magic is to make this feel really fluid. And the way that's accomplished in large part is by setting up this state machine where, based on where your hands are in space, the buttons on your devices perform different things. So there's almost this sense of like naturally observing the context of what the user is trying to do, and then when they click, it just sort of does the right thing because we know how to react based on where you are in space. Okay. So in the end, with this approach, what you end up doing is you create these vertical vectors. It's almost like a feature vector for your data, you know, and each column, here's like the visual volumetric summary of the interesting parts of the data set, okay? And then I can rearrange those columns to get the proper ones next to each other to compare. So if we return back to the original question, let me give you a few thoughts to go away with. So how do you sort of support this walking inside your data? One big lesson learned is support visual comparisons as a first-class citizen. When we do computer games and movies, the default approach in computer graphics is you've got one virtual camera and you fill the screen with it, and that's that. Okay? But when you talk to scientists or engineers or even scholars of rhetoric, it's comparisons that they want to do. So if we're really treating that as our goal, how do we support that task? And you have to design for that in your visuals. Bring work from outside of VR into the immersive space. We've got to find some way to link these spaces. It can't be that I leave my life and go into virtual reality. Okay. Use two hands rather than add more buttons, which nobody can remember anyway. Use context to figure out how to control visualizations. Mix these 2D and 3D data displays. Okay, we've got great 2D visualizations. There's no reason when you go into VR to leave all those behind. And marry this idea, as you see from a lot of the speakers here, of advanced multivariate data visualization together with the interaction techniques that allow you to explore your data. So it's not just about make a picture where all of a sudden, because I'm in 3D, I can see something new. It's like, how do I enable a process? And for that, you need interaction techniques. Okay, so that's kind of my quick answer to how. And the when gets back to the experience. Go into these immersive VR environments when you need to experience your data and put your hands into it and judge it relative to your physical scale. That's when these really work. Okay, so let me say thanks to all the people who helped here, and thank you very much.
Questions for a speaker? Back there.
I have a question about your setup. Did you ever try this in a dome space instead of I noticed like 4 walls, basically 3 walls?
Yeah, this was
Can you repeat the question?
I can repeat for you. The question was, did you try any of this in a dome space rather than sort of a cube-like space? And the answer is, briefly, no. The more detailed answer is, a number of these also run in head-mounted display environments, and so in some sense the software is sort of agnostic to where you run it. A dome would also work, but of course the projection's trickier to get just right, and we happen to have the cube display. We've started doing a little bit with planetariums, but those typically do not have the stereoscopic style of projection, and so it really again, it comes back to some of the answers to questions earlier. It depends what you're after. So for the things where we're looking at near space data, a heart or a brain, or we're designing with our hands, this stereo vision is really critical. For the things where you're looking out off in a distance, it's less critical. So that would be a better choice for one of these planetariums that doesn't have a stereo display, for example. But when we're in the near space, we like to work with a stereo environment. It could be a head-mounted display, but honestly, a lot of these involve multiple scientists working together, and the ability to sort of be in the same physical space while you're in this virtual space and have a conversation can really help without something blocking your head. So we tend to prefer the projection for that reason.
So if I can abuse my chair's privilege, I'll make a comment about this. I think an excellent reason when to walk in your data is the collaborative visualization and collaborative visual exploration of the data. And people do not have to share the same physical space. That's the whole point. They can be all over the world but share the same virtual space.
I thought it was interesting, your Phoenix example. The first thing I wanted to ask was, like, did you incorporate sound into your visualization? And that was great. I don't know if it's more of a comment than a question, but it was interesting because the first amphitheater you showed was an amphitheater, and those are designed to have sound so one speaker all the audience can hear that one speaker. And when you change it to a flat ground, you change the sound dynamics that sound doesn't carry as far, and also you can't see as many people.
Yeah.
So I thought that was really interesting to show. But have you thought about the other thing of other feedback? You know, we're talking about visualization, but you know, oral feedback, tactile feedback, haptic feedback. Have you done any of that in terms of like your sculptures? If you could, like, when you reach out, you touch it, so it becomes a solid surface and not just a thing you pass through.
Yes. Yes, 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 yes. Although it's fantastic. You know, actually we've been working with sound the other way in the Phoenix also with the speaker actually speaking, and then you can travel out into the audience and see if you can hear it. Yeah, and right now our sound simulations are pretty rudimentary, but of course that's the next step, is to really beef those up. On the haptic front, we've done a fair amount there too, and there's sort of two directions we've been looking at. One is with active haptics, where you have a force feedback device that you're holding. And my dissertation actually was on the topic of extending that 3D drawing approach to a situation where you could sort of feel as you're drawing. So you had friction, like you're drawing against paper, and you could actually push to increase the line weight, the thickness of the line as you're drawing. And it really creates a different experience, and if you do it right, you can actually make it quite controllable, which is one of the tricks with working in space. However, more recently, we've been going towards sort of cheap haptics. And by cheap, I can mean really cheap. Like, we just created a system a few years ago with a rolled up piece of paper. And the rolled up piece of paper becomes a passive haptic prop. And so looking at microscopy data, the first thing you want to do is look at these fibers and highlight which ones are moving in this direction versus this direction and so forth. Well, what's the easiest way to indicate a 3D direction of the computer? You just point. You know, so with a Kinect depth camera, we detect which direction you're pointing this thing, and then that becomes like a perfect input. And then you need a slider where you just sort of move your hand up and down on this roll of paper, and all of a sudden you've got not something active, but a passive thing to hold your hand against. And that becomes actually a real aid in getting controlled input. So there's a whole branch of things we've been doing in that direction too, which, like, even without adding really expensive devices, just use your physical environment. It could be a touch screen even, where you're doing some gestures just above it that give you some support, and that additional support actually helps you be more accurate in these interaction techniques.
So let's thank our speaker again.